Coral bleaching. Context. As of this year, mass bleaching has killed more than one-third of the corals in the northern and central parts of Australia's Great Barrier Reef. The corals to the south have escaped with little damage. Of the 2,300 square kilometer reef of Australia's east coast, it is found that around 35% of the corals in the northern and central sections of the reef are dead or dying, and some parts of the reef have lost more than half of the corals to bleaching. Of the issue. The issue is significant from the point of both prelims as well as mains. However, in case of prelims, the issue increases the significance of a number of aspects from the basic syllabus, a trend we have witnessed in the recent past, such as corals, coral reef formation, ocean water temperature, ocean salinity, factors related with the mentioned phenomena. As from the point of mains, coral bleaching forms part of GS Mains Paper 3, especially of the section of Environment and Environmental Impact Assessment. Coral reefs formation. Coral reefs are found in circumtropical shallow waters along the shores of islands and continents. The reef substrate is mainly composed of calcium carbonate from living and dead corals. Many other invertebrates, vertebrates, plants live in close association to the corals with tight resource coupling and recycling, allowing coral reefs to have extremely high productivity and biodiversity, such that they are referred to as the tropical rainforests of the oceans. Corals live in very nutrient-poor waters and have certain zones of tolerance to water temperature, salinity, UV radiation, opacity, and nutrient quality. Zooxanthellae live symbiotically within the coral polyp tissues and assist the coral in nutrient production through its photosynthetic activities. These activities provide the coral with fixed carbon compounds for energy, enhanced calcification, and mediate elemental nutrient flux. The host coral polyp in return provides its zooxanthellae with a protected environment to live within and a steady supply of carbon dioxide for its photosynthetic processes. The symbiotic relationship allows the slow-growing corals to compete with the faster-growing multicellular algae because the tight coupling of resources and the fact that corals can feed by day through photosynthesis and by night through predation. The tissues of corals themselves are actually not the beautiful colors of the coral reef, but are instead clear. The corals receive their coloration from the zooxanthellae living within their tissues. Geographical conditions required. Corals generally flourish in clear tropical oceans, usually between 30° north and 30° south of the equator. They grow best in the brightly lighted waters about 5 to 10 meters deep. The suspended particles interfere with feeding. Corals live in saline water. Coral reef can form to depth of 90 meters, but a growth rate declines rapidly after 5 to 10 meters depth. The reef-building corals are found within the 21° isotherm. Corals are not near the mouths of the rivers. Temperature below 18° centigrade causes their death. Individual coral organisms are however found in some cold, high-latitude waters as well, such as Norway, Cape Verdes, and off the New Zealand and Japan coast. Types of reefs. In 1842, Charles Darwin classified tropical reef structures into these types. Fringing reefs. A coral reef which is attached to the shore either as a continuous wave-washed erosion platform or separated from the coastline by a shallow lagoon. Beyond its seawards margin, the ocean water deepens rapidly. The fringing reefs are generally not very wide, and where a river enters the sea from the land, they become broken and discontinuous. Fringing reefs are formed in areas of low rainfall. The greatest concentration of the corals is on the seaward edge. Fringing reefs are found in New Hebrides, Society Islands, and coast of Florida. Barrier reef. This is an elongated accumulation of corals lying at the low tide level parallel to the coast, but separated by a wide and deep lagoon or strait. The lagoon does not permit coral growth. The lagoon may vary in width from a narrow channel to many miles. The Great Barrier Reef of Australia is the largest biological structure made by corals on the planet. Atoll. Normal atoll is a ring-shaped island that encircles a central lagoon. Atolls are mainly found in the Pacific Ocean, such as Fiji atolls, and in the Indian Ocean, such as in the Lakshadweep, and Maldives. The reefs of seas around India. All the three major reef types occur in India, such as atolls, fringy and barrier reefs. Within these habitats, some of the most diverse, extensive and least disturbed reefs exist in and around Indian subcontinent. The mainland coast of India has two widely separated areas containing reefs. The Gulf of Kutch in the northwest, which is some of the most northerly reefs in the world, and Pork Bay and Gulf of Mannar in the southeast. In addition to these, there are patches of reefs on the west coast, for example, coral reefs of Malvan. Andaman and Nicobar Islands have fringing reefs around many islands and a long barrier reef around 329 kilometers on the west coast. Little is known about these reefs, which may be the most diverse and pristine reefs in India. The Lakshadweep also has extensive reefs, but these are also poorly explored. The fringing reefs are contiguous with the shore and they are the most common by occurring reef forms found in Andamans. Patch reefs are isolated and discontinuous patches lying shoreward of offshore reef structures and are seen in the Gulf of Mannar and Kutch. Barrier reefs are linear offshore reef structures that run parallel to coastlines and arise from submerged shelf platforms. The water body between the reef and the shore is termed as lagoon. Barrier reefs are seen in Nicobar and Lakshadweep. Atolls are circular or semicircular reefs that arise from the subsiding seafloor platforms as coral reef building keep ahead of subsidence. The examples are the atolls of Lakshadweep and Nicobar. When the reef building does not keep pace with subsidence, reefs become submerged banks, as seen again in Lakshadweep. Indian coral reefs are mainly in Andaman and Nicobar and Lakshadweep Islands. On the mainland, coral reef formations are found in Pork Bay, Gulf of Mannar, Gulf of Kutch and Malvan coast. The total coral reef area in India is 5,790 square kilometer, distributed between four major regions: Lakshadweep, Gulf of Mannar, Gulf of Kutch and Andaman and Nicobar Islands. Corals have also been reported from Gaveshani Bank around 100 km offshore from Mangalore and several areas along the eastern and western coast of mainland India. Example, the Malvan Coral Reef Sanctuary near Mumbai. Large areas of coral reefs of India, with the exception of the Andaman and Nicobar Islands, were severely affected by the 1998 coral bleaching event. Reef resources are heavily exploited, particularly in the Gulf of Mannar and Gulf of Kutch, and to a lesser degree in the Lakshadweep and Andaman and Nicobar Islands. Causes of coral bleaching. Coral bleaching is caused by the healthy coral reef losing its tiny single-cell algae and usually occurs quite suddenly. Coral bleaching is known to be responsible for killing approximately 18% of the world's coral reefs. Coral bleaching in most cases is triggered by the introduction of warmer water than normal to the local ecosystem. The different causes of coral bleaching are discussed as follows. Ecological causes of coral bleaching. As coral reef bleaching is a general response to stress, it can be induced by a variety of factors alone or in combination. The following stressors have been implicated in coral reef bleaching events. Temperature. Coral species live within a relatively narrow temperature margin, and anomalously low and high sea temperatures can induce coral bleaching. Bleaching events occur during the sudden temperature drops accompanying intense upwelling episodes and seasonal cold air outbreaks. Bleaching is much more frequently reported from elevated seawater temperature. A small positive anomaly of 1 to 2 degrees centigrade for 5 to 10 weeks during the summer season will usually induce bleaching. Solar irradiation. Bleaching during the summer months during seasonal temperature and irradiation maxima often occurs disproportionately in shallow living corals and on the exposed summits of colonies. Solar radiation has been suspected to play a role in coral bleaching. Both photosynthetically active radiation and ultraviolet radiation have been implicated in bleaching. Subaerial exposure. Sudden exposure of reef flat corals to the atmosphere during events such as extreme low tides, insulated sea level drops, or tectonic uplift can potentially induce bleaching. The consequent exposure to high or low temperatures, increased coral radiation, desiccation, and seawater dilution by heavy rains could also play a role in zooxanthellae loss, but could also very well lead to coral death. Freshwater dilution. Rapid dilution of reef waters from storm-generated precipitation and runoff has been demonstrated to cause coral reef bleaching. Generally, such bleaching events are rare and confined to relatively small near-shore areas. Inorganic nutrients. Rather than causing coral reef bleaching, an increase in ambient elemental nutrient concentration, example ammonia and nitrate, actually increases zooxanthellae density by 2 to 3 times. Although eutrophication is not directly involved in zooxanthellae loss, it could cause secondary adverse effects such as lowering of coral resistance and greater susceptibility to diseases. Xenobiotics. Zooxanthellae loss occurs during exposure of coral to elevated concentrations of various chemical contaminants such as copper, herbicides, and oil. Because high concentrations of xenobiotics are required to induce zooxanthellae loss, bleaching from such sources is usually extremely localized and or transitory. Storms and rainfall. Storms, rainfall, and floods are all natural, regularly occurring events on the Great Barrier Reef, and as such play a role in the ecosystem. However, predictions suggest an increase in the frequency of severe weather events, which would lead to more serious physical damage with less time between events to recover. The most immediate impact is coral breakage, dislocation, and degradation from wind and waves. However, the effect does not stop here. Heavy rainfall events lead to flood plumes stretching across the reef, exposing inshore coral reefs to freshwater inundations. Freshwater runoffs reduces salinity levels, sometimes causing bleaching, and brings increased nutrients and sediments, which can lead to disease outbreaks, algae blooms, and murky water reducing light reaching to corals. The vulnerability of coral reefs to these impacts is dependent on the effect of other climate change impacts. For example, reefs that are weakened by ocean acidification or stressed from high sea surface temperatures will respond poorly to a major storm or flood event. Anthropogenic causes of coral bleaching. Coral mining. Corals constitute the single most intensively exploited resource from the reefs, especially those of Gulf of Mannar and Gulf of Kutch. In Gulf of Mannar, mining of corals is mainly from the eastern and northern shores of the islands, which are protected from wave action. Quarrying is more intensive along the northernmost islands, with an estimated removal of about 25,000 tons a year, which continued through the 80s. As the mining is done only manually, it is confined to waters less than 1 meter deep, and consequently, destruction of live coral cover is great, and occasionally by as much as 100%. Similarly, coral mining near Tuticorin results in an annual removal of about 15,000 tons of coral blocks and 10,000 tons of coral debris. Harvesting of other coral resources such as shells, holothurians, seaweeds, and fishing near the reefs have contributed to further degradation of the reefs. In the Gulf of Kutch, extraction of calcareous sand for use as raw material in a cement factory is the major form of resource exploitation. The removal, estimated to be at between 0.6 and 1 million tons, has destroyed live coral cover to the extent of 50%, mainly through the increase in turbidity and disposition of thick layers of silt on corals. Coral removal in Andaman Nicobar and Lakshadweep Islands is mainly for local needs, such as building construction or laying of roads, and no commercial industry exists in these islands. However, increased localized exploitation associated with population pressure in smaller islands such as Kavaratti and Minicoy has led to serious shore erosion. Shell and coral collection. Collection of molluscan shells for local trade and export is a major activity in the Gulf of Mannar, Andaman and Nicobar Islands. In Gulf of Mannar, in the region of Rameshwaram and Tuticorin, shells like cowries, cones, volutes, Murices, storm beads, etc. are collected on a commercial scale and sold locally or exported. Near Tuticorin, collection of chunk shells is as much of economic importance as that of smaller ornamental shells. In Andaman and Nicobar Islands, Tarbo and Trocus are the two genera extensively collected, apart from a variety of cowrie shells. Along the mainland coast, collection of Ramos corals for sale to tourists is a lucrative business. Corals of the genera Acropora and Poculopora are particularly preferred as they are the most decorative and fetch a high price. Corals are usually collected from Gulf of Mannar reefs but are sold even at far away tourist spots like Cape Comorin or Chennai. In the Lakshadweep Islands, coral collection was rampant in the last decade, resulting in a total loss of Ramos corals from the lagoon of many islands, especially Kavaratti. Sale of corals was through a government-sponsored handicraft emporium, but most of the corals were collected to be given away as gifts or souvenirs to visitors from the mainland. Now there is a total ban on removal of corals, and this ban appears to be implemented seriously. However, collection and sale of corals continue in the Andaman Islands. Selective removal of Ramos corals affects the zonation and creates an imbalance in the ecosystem. For example, the Kavaratti lagoon, abundant with many species, is now totally devoid of these. Consequently, the rocky substrates within the lagoon are overgrown with algae, thus depriving sites for new coral settlement. Secondly, it deprives the habitat of reef fishes which are associated with these coral colonies. Most of these fishes have economic value as ornamental fishes. Thirdly, the reef growth or recovery is seriously reduced since the Ramos forms precipitate calcium at rates several times greater than the massive forms do. Fishing. Potential food fishing yield from coral reefs is in the range of 10 to 15 tons per kilometer per 2 year, and for the Indian reef areas. Present exploited yield is, though hardly a fraction of this, and much of it is only for sustenance. The reasons being the uneven topography which precludes use of large gears and the remoteness of many reef areas. Nevertheless, even artisanal fishing is attendant with serious damage to reefs. For example, in Kilton, fishing is done by covering corals with small nets and breaking off the branched corals to drive out the resident fishes. This is a common practice in many other reef areas also, and the reported scarcity of food fishes may not necessarily be due to overexploitation but due to habitat destruction. Fishing by lines or harpoons is least damaging to the reefs. Destructive procedures of fishing by poisons or dynamite do not exist, since these products are not readily accessible to common fishermen. Scientific collections. Overzealous and uncontrolled collection by students and scientists has caused damages to some reef areas. The best known example is the Gulf of Mannar, visited by student groups for past several decades. Now the reef is practically dead, and it is perhaps the only reef in that region that is heterotrophic. The Lakshadweep reefs are becoming open to visits by student groups, and it is only a matter of time before irreparable damage is done. Though there is a ban on coral removal, scientific collections are exempt, but no rules exist to regulate them. Damages due to developmental activities. These are of isolated instances. In the Pokbay reef, effluents from a fish meal plant at Mandapam were responsible for coral bleaching in some parts of the reef. In Gulf of Mannar, there was a progressive disappearance of live coral reefs inside the Tuticorin harbour and surrounding areas due to increased ship movement, oil spillage, and increase in marine-based industries. In the high islands of Andaman, widespread deforestation has resulted in soil erosion, washing of sediments by river runoffs, and massive siltation on the fringing reefs. In Port Blair, Mayabandar, and other areas, effluents from timber factories have been responsible for large-scale mortality of reef corals. Ocean acidification. When carbon dioxide is absorbed by seawater, chemical reactions occur that reduce seawater pH, carbonate ion concentration, and saturation states of biologically important calcium carbonate minerals. These chemical reactions are termed ocean acidification. Calcium carbonate minerals are the building blocks of the skeletons and shells of many marine organisms. But excessive carbon in the atmosphere from the burning of fossil fuels over the last 2 centuries have caused increased acidity in the oceans, which is threatening ecosystems, sea creatures and other food supplies. These rising levels of acidity, along with the effects of global warming, could affect the ability of oceans to absorb greenhouse gases. Since the beginning of the Industrial Revolution, the pH of surface ocean waters has fallen by 0.1 pH units. Ocean acidification is expected to impact ocean species to varying degrees. Photosynthetic algae and seagrasses may benefit from higher carbon dioxide conditions in the ocean, as they require carbon dioxide to live just like plants on land. On the other hand, studies have shown that a more acidic environment has a dramatic effect on some calcifying species, including oysters, clams, sea urchins, shallow water corals, deep sea corals, and calcareous planktons. Biological impacts on corals. Many marine organisms that produce calcium carbonate shells or skeletons are negatively impacted by increasing carbon dioxide levels and decreasing pH in seawater. For example, increasing ocean acidification has been shown to significantly reduce the ability of reef-building corals to produce their skeletons. Coral diseases. Corals are also affected by various fungal and bacterial diseases. In Gulf of Mannar and Lakshadweep, different diseases have been recorded in the recent past. Silt and sedimentation cause asphyxia on polyps and corals die. Sea erosion, dredging the reef environments, deforestation, and construction activities stir up silt and sediment. Pests and predators also cause death of corals. Blasting of the reef is a human activity that causes destruction of reefs. In the post-independent years, introduction of mechanized fishing crafts resulted in the blasting of reefs to deepen the boat channel in Lakshadweep. Pairing of corals for various industrial purposes and construction work in Gulf of Mannar resulted in the total loss of fringing reefs in some islands. Dredging the lagoon for navigational purposes degraded the atoll reefs of the Lakshadweep. Only in some parts of Nicobar Islands and Andaman, undisturbed reefs remain. Consequences of coral bleaching. Effects of mass bleaching on coral cover and biodiversity. The temperature sensitivity of corals and the likely limitation in their rate of acclimatization and adaptation suggests that coral reefs are likely to have less live coral cover and lower biodiversity as a result of increases in the frequency and severity of mass bleaching events. The loss of these species is likely to have a noticeable impact. It may alter the amount of habitat for many reef-dependent species. Further, the differences in bleaching susceptibility among corals will result in significant shifts in the community structure of coral reefs. This change is likely to result in follow-on effects to other organisms, as many species, including a variety of fish and invertebrates, are dependent on the habitat provided by branching corals. Differences in ability of species to migrate and to adapt will further exacerbate changes in community structure due to differential mortality from severe bleaching. If bleaching events become increasingly frequent, the more susceptible species may have trouble re-establishing between bleaching events, leaving abundant space available for algal growth. Decreasing time intervals between bleaching events would also limit opportunities for resistant species to establish sustainable populations before temperatures increase again. Impacts on fisheries. Changes in coral reef ecosystems result from bleaching are expected to translate into shifts in fish species consumption and possibly reduce fishery catches. Coral reef ecosystems support fisheries by providing food and habitat for a diversity of species. Coral mortality from the mass bleaching events lead to loss of reef structure and habitat, as dead coral skeletons erode and break down. However, the effects of coral bleaching events can extend over hundreds of thousands of kilometers, causing stress or damage on scales not normally experienced by coral reef ecosystems. Where significant coral mortality occurs, coral bleaching can result in dramatic decreases in the amount of habitat available for fish and other mobile reef species that depend on the structure provided by healthy coral reefs. strongly coral-dependent fish species are expected to be the most affected by bleaching-induced coral mortality. Impact on tourism. Changes in coral reef ecosystems resulting from bleaching are expected to translate into economic losses to the tourism industry. The extent of impact on tourism businesses varies with the flexibility of individual markets. For example, dive businesses that are based in population centers are likely to be more capable of responding to changes in reef quality caused by mass bleaching, because they may be able to shift from a focus on providing high quality dive sites for experienced divers to new divers expecting instruction, or even to non-divers. By comparison, mass bleaching may significantly affect businesses based on taking divers to remote locations that are renowned for exceptional coral reef quality. In the end, I would request you to look into the PDF provided below to get an idea about the possible questions on this issue. The questions provided are only samples. There can be other types of questions as well on this issue. Thank you.